Question of the Week from the Naked Scientists.
Hello, and welcome to Question of the Week. I'm Alexandra Ashcroft, and this week we've aired out Norm's question.
If water, or H2O, is a solid, as ice, below 0 degrees Celsius, a gas above 100 degrees Celsius, and a liquid between this range, why then does my washing dry when the air temperature is below 100 degrees?
I asked Thomas Aldridge from Imperial College London to hang Norm's question out to dry.
It is true that pure water will normally be a gas, called water vapour, only above 100 degrees Celsius, but temperature isn't the only factor at play here. The surrounding pressure also impacts when a substance like water can be a gas. The higher the pressure, the higher the temperature required for the gas to be stable. You've probably all heard of LPG, which stands for liquefied petroleum gas. The chemicals in LPG would normally be a gas, but by keeping LPG in high pressure canisters, it can be stored as a liquid.
So gases like overfilled balloons often can't handle the pressure. But why is this?
To exist as a gas, water molecules have to be widely spaced out. High enough pressure will tend to squeeze them back into their more compact liquid form. The more you heat water, the more energy you give to the individual molecules, and the harder they can push back against their surroundings. Above 100 degrees Celsius, but not below, water molecules can push back hard enough against the pressure of the atmosphere for pure water to stay as a gas of widely spaced molecules.
It's all about the pressure then. So what's going on when our clothes dry?
Well, let's consider a puddle, for example. You might think it should stay as a liquid because the temperature is below 100 degrees and the atmosphere is pushing down on it. However, we don't only have water molecules involved, the system isn't pure. The air above the surface of the puddle contains many other molecules, such as nitrogen and oxygen. These extra molecules can actually help to push back against the surrounding atmosphere, effectively lowering the pressure that must be supported by the water molecules themselves, if they form a gas. It's like many people helping to lift a weight rather than just one. In fact, there's so much more nitrogen and oxygen, they take almost all of the burden of the atmospheric pressure. And this is important. It means that any water molecules that have enough energy to escape from the puddle don't face the full might of the atmospheric pressure, so they don't immediately liquidise. This is why some water vapour can survive in the atmosphere, thanks to the hard work of the other gases, and thus we can explain why evaporation happens, and why puddles or clothes dry under normal conditions. Of course, only a certain amount of water vapour can actually be supported by the other gases, which is why things don't evaporate immediately and why movement of air is important if you want things to dry faster.
If you want to see this in action for yourself, lick your wrist and blow on it. It dries almost immediately compared to if you don't blow. So that's evaporation covered, but what about boiling?
When water reaches 100 degrees at atmospheric pressure, the individual molecules have so much energy that the vapour no longer needs the help of the other gases to be stable. In our analogy, the water vapour is now like a weightlifter that is strong enough to support the weight of the atmosphere on its own. At this point, bubbles of vapour can form within the liquid itself, converting liquid to gas much faster than the slow evaporation would from the surface of liquid water.
Thanks to Thomas Aldridge for ironing that out. Next time, we'll answer David's question.
Science has attempted to try and measure the intelligence of other primates, dolphins, birds, and many other species of animals. My question is, how does your average, ordinary pet dog measure up in comparison?
Do you think you know the answer? Well, get in touch and let us know. You can email chris@nakedscientist.com, find us on Facebook, or tweet @nakedscientist. You can also join the debate on our forum. That's nakedscientist.com/forum. Until next time, goodbye.